Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook. This one type of question, rationalising a denominator involving surds, cost students more marks than almost anything else on last year's AQA Higher paper. It's not because it's hard, it's because of tiny method slips. If you listen to the next 12 minutes, you will stop losing those routine marks. Sound familiar?
That sounds like me. I knew the answer once, but I lost marks because my working looked messy. Ready to fix that.
The concept. First, the rules you must know in plain language. Rule 1. Turn surds into index form. A square root, like root x, is x to the power 1/2, written x to the power 1/2. Writing roots as powers makes the rules for multiplying and dividing obvious. Rule 2. Laws of indices. When you multiply, add the powers. When you divide, subtract the powers. When you take a power of a power, multiply the powers. These are the same rules you use for ordinary indices, now applied to fractional powers.
Rule 3. Simplifying a surd. If you can write the number inside a root as a product that includes a square, take the square out. Example, square root of 18 is equal to square root of 9 times 2 is equal to 3 square root of 2. This is the small simplification that usually wins the final mark. Now, a single worked example using algebraic form so you can apply it to any numbers. Simplify a root b over c root d. Step 1. Write the surds as fractional powers. That gives a b to the power 1/2 over c d to the power 1/2. Write it out exactly like that. Examiners like to see the conversion.
Step 2. Group the constants and the surd parts. So we have a over c multiplied by b to the power of 1/2 over d to the power of 1/2. Using the division rule, b to the power of 1/2 over d to the power of 1/2 equals b over d to the power of 1/2. So the expression becomes a over c multiplied by b over d to the power of 1/2. That's a neat simplified form, and we did it with index rules. So we don't have to do anything weird like cancel the roots directly. We just turn them to powers and use the subtraction rule. Exactly. Turning to powers avoids the temptation to cancel across sums or make slip errors. One more step many exam questions require is rationalising the denominator, removing any surd from the bottom. If the denominator is a single root, like root d, multiply numerator and denominator by root d. That gives a root b times root d over cd, which simplifies to a root bd over cd. If you prefer indices, multiplying by root d is multiplying by d to the half. The surd parts multiply. b to the half multiplied by d to the half equals bd to the half. Either way, show your steps. Don't skip lines. Examiners award method marks for clear intermediate work. Quick question. What if the denominator is a sum, like 3 plus root 2? How does rationalisation change? Good question. For a sum, you multiply top and bottom by the conjugate, 3 minus root 2. That removes the surd because 3 plus root 2 multiplied by 3 minus root 2 equals 9 minus 2, a rational number. We'll focus today on single root denominators, but remember that conjugate trick for binomials. The exam technique, what examiners want to see, and how marks are usually split. For a typical rationalisation question worth 3 marks, you get M1 for writing your surds in a suitable form or setting up the multiplication to rationalise, M1 for carrying out the key algebraic step correctly, and A1 for the fully simplified final answer. Write each key line. That turns your understanding into marks. Concrete example of method lines to write. Line 1. A root b over c root d equals a over c multiplied by b to the half over d to the half equals A over C, B over D to the half. If rationalising, multiply top and bottom by root D. Show the product in numerator and the D in the denominator, then simplify inside the root if possible. Even if you can't finish, that first line often earns M1. Write it down, don't just think it. Common mistakes that cost marks. Skipping the fractional power step, cancelling terms across addition, and forgetting to multiply the numerator when you rationalise the denominator. Also, not simplifying the root at the end. Giving root 8 instead of 2 root 2 loses the final accuracy mark. So the examiner is watching the method as much as the final answer. If I show the index step and the multiplication, I've got a good chance of scoring, even if I slip the final simplification.
Exactly. Marks are there for the taking. The quick win, a 10-second checklist to use every time you see surds and indices. Say it with me. Convert, simplify, rationalise, check. Convert the surds to fractional powers, simplify inside roots by pulling out squares, rationalise if the denominator has a root, then check quickly by substitution or squaring if needed.
A fast rationalisation trick under time pressure. If the denominator is a single root, root D, multiply top and bottom by root D, instant removal of the root and a denominator of D. If it's a plus or minus expression, spot the conjugate and use it, and a mental check. If your final denominator is an integer, you probably did the rationalisation step correctly. Practice mini question. Try this with me. I'll give you 90 seconds to attempt, then I will walk through the solution. Question. Simplify and rationalise the denominator of 3 root 18 divided by 2 root 2. Pause the episode now, or use the next 90 seconds to work it out. Ready?
Okay, I've got an answer. I simplified root 18 to 3 root 2, so the numerator became 9 root 2. Then I cancelled root 2 with root 2 in the denominator, but I'm not sure that's allowed.
Good attempt. Let's walk it through correctly, so you see where common slips happen. Step 1. Simplify root 18 equals root 9 times 2 equals 3 root 2. So the numerator, 3 root 18, becomes 3 times 3 root 2 equals 9 root 2. So the fraction is root 9 root 2 all divided by 2 root 2. Now here's the key. You can cancel root 2 top and bottom because it's a factor. This is division of factors, not cancellation across addition. Cancelling gives 9 over 2. That means the surd disappears completely in this case.
Wait, so you can cancel the roots when they're multiplied, but not when they're added? That was my mistake earlier. I was worried it wasn't allowed.
Exactly. That cancellation is allowed because both numerator and denominator had root 2 as a factor. A slower common mistake is to try and cancel pieces of sums. Another example, if the numerator had been root 18 plus 1, you cannot cancel the root 2 part across an addition. Mark-wise, show the simplification step root 18 equals 3 root 2, then show the cancellation clearly. 9 root 2 divided by 2 root 2 equals 9 over 2. That's 2 method steps and the final answer. If after cancellation a denominator still has a surd, rationalise using the multiply by root trick we discussed. Remember to write the intermediate line, multiply top and bottom by the same root, and show the simplified denominator as an integer. That line often gets you an M1, which is worth a lot in short papers.
That 10-second checklist is already sticking. Convert, simplify, rationalise, check. I'll run that every time I see a surd. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and a printable cheat sheet covering surds, indices and rationalisation at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.